Thank you, Barry, for giving the intro. I can skip my introduction as far as my background. I did spend 8 years in the U.S. intelligence community, mostly at NSA. As both a civilian intelligence analyst as well as a contractor. Shortly after starting at NSA and beginning my work in the intelligence field, I quickly went to cybersecurity. I started leading teams in computer network operations and network intrusion discovery. And quickly, fell in love more with technology and wanted to make that a part of my career. I then moved back home to upstate New York, where I'm originally from, to work at Apprenda and work in their product management group because I enjoy building things. I'm a part of the product management team building our Apprenda cloud platform. I also am heavily involved in internal projects around DevOps and platform security. Definitely still an important part of my career, and I like to incorporate that in my day job as much as possible. I put Apprenda in bold here, not so much to advertise the company itself, but I want you all to know that I do come from a vendor. We have our view of the world. I don't want you all to think that is the only view. There are other vendors in our market that I encourage you to seek their opinions on their views of the world. But just so you know, representing a vendor at a conference, this is how we see cybersecurity, and it's shaped in how we build our product. So setting the stage here, everyone is building software today. Everyone is utilizing software to get business value. Whether you're a bank, whether you're a manufacturer or a retail giant, you're in professional services, whether you're a software company, you're building software. In effect, all these other industries, all the companies in those industries and organizations, non-for-profits and governments, they're all software companies too, because they're all getting value out of the software that they build. They're getting business and mission value out of it. And as a result, you're starting to see companies that traditionally were nowhere close to being, what you would think of as a tech company, becoming tech companies themselves. Caterpillar builds bulldozers, heavy machinery, mining equipment, and they build software. Nike builds software. Home Depot builds software. And as a result, you're starting to see them move into new types of technologies where they can innovate faster, get more business value quicker, and deploy more software in cloud environments. And today's talk is going to be around cloud application platforms and how enterprises are getting significant value from cloud platforms so that they can deploy and scale custom-built web applications using these platforms. So what do I mean by a cloud application platform? Well, I'm talking about a vehicle that allows users to deploy and scale applications in a cloud environment. And they get to take advantage of benefits of cloud, like getting scaling as a part of their applications. They're able to get fault tolerance. They're able to get availability. All these benefits they inherit when they move to a cloud-based architecture. And cloud platforms are abstracting away the complexities that typically developers had to manage when deploying their applications. They had to worry about infrastructure. They had to configure their containers and their servers. And cloud platforms are automating that so that developers don't have to do that, and they can innovate and focus on the business logic of their applications alone. Now, cloud platforms in this talk too, you might think that you're only talking about public cloud, about Amazon Web Services, about Microsoft Azure or Google Compute Engine. Well, cloud platforms can be deployed on premises too. They can be in an enterprise data center. They can be in a location of their choosing, because for security reasons, they may want to have more control over their environment, but still take advantage of the benefits that cloud has to offer. And now we've arrived at a place where different technologies, different architectures, different terminology is creating a lot of confusion. That there are new ways, new proposals out there for how to run applications in a cloud environment, that it's causing a lot of disruption, and also a place where enterprises are like, where do I start? How do I know what technology is right for me? And I hope to utilize this conversation to talk about the three types and to maybe dispel some of the confusion and create some clarity around what type of architectures and tech are being used. And the first I'm going to talk about is platform as a service. It's a way in which an enterprise can offer a service, a platform for developers to deploy and scale applications. Simple as that. The next I'm going to talk about are container orchestration, or container orchestrators, and sometimes called cluster managers, that are coming as of late that are helping to manage what are known as software containers in a clustered format. And the last I'm going to talk about a really confusing term called serverless, and more on that later. So platform as a service, I talked about how it's a computing platform where customers are software developers. Traditionally, when you think of software as a service, we're the end users, we're the customers. If I want to file my taxes with TurboTax, software as a service, it's deployed in the cloud, I'm the customer of that. Infrastructure as a service, on the other hand, is something where IT or someone who manages infrastructure would generally be the customer. But in this case, platform as a service, the developer is the customer. And it's a vehicle for developers to deploy and scale and configure their applications. IT operations in the PaaS model manages the underlying infrastructure. They manage all the dependencies needed in order to run the platform that traditionally developers had to manage themselves. So runtime, middleware, containers, operating systems, virtualization, storage, networking, all of that is handled by the platform or handled by IT via some other integration with other technology. And developers only focus on the business logic of their applications. Container orchestration. So we have Docker and a few other companies, such as CoreOS, to thank for creating a world where now we're introduced to what is known as the lightweight software container. And what is that? Well, it's an additional layer of abstraction between the user and the operating system virtualization. It's creating a isolation mechanism inside the operating system using low-level integrations and low-level system calls to isolate resources, file systems, and processes, and even networking to a point where now you almost have a mini operating system inside a larger operating system. And you ask, doesn't VM type technologies, doesn't virtual machines, kind of do that too? Well, yes, it does, but in a virtual machine, you are dependent on a hypervisor to manage virtual machines. And I emphasize the word lightweight here because containers are creating a world where you don't need that overhead of the hypervisor. You can just quickly, in an automated fashion, spin up a container and create that isolation without much overhead. And you can do so dynamically so that containers are more ephemeral in nature. And it's really a huge cost savings for innovating because now it doesn't require the same management, the same resources to spin up a container. And enterprises are taking advantage of it because it's providing isolation and it's providing a mechanism for innovation. Now, containers were the first part, but container orchestrators are the second part that really make what containers are doing, a system operation where now you can utilize any number of containers to deploy, scale, and manage any number of applications. Orchestrators are introducing us to the concept of managing cattle as opposed to just managing pets. A container is a pet, a server is a pet. Container orchestrators are saying, think of your containers as a cluster and manage the cluster and utilize containers and the agility of containers to spin up instances and take instances down as you need them, saving on costs and getting still isolation of processes. And in this world of container orchestration, there's one technology that happens to be leading the way, and that's a container orchestration system called Kubernetes. Kubernetes is in the pole position based on web searches with other container orchestrators at the current state. Kubernetes is gaining much more traction in enterprises, in self-help. Again, this is Apprenda's view of the world, but we have data to back up that Kubernetes is actually leading the way. And now you ask yourself, what is Kubernetes? Well, Google saw what Docker was doing and said, well, we've been running containerized workloads in production for more than a decade. And that was a system that we called the Borg system. And they've been running web applications, infrastructure systems such as the systems and big data platforms that power Google search. They've been running that for a decade at Google scale, meaning tens of thousands of servers, tens of thousands of containers, and tens of thousands of applications, even within a single cluster. And they decided to publish the details of this Borg system and release an OSS version called Kubernetes. And enterprises are investing in Kubernetes because, hey, if Google's doing it, if Google proved it out, if they had 10 years of doing this in production at their scale, well, I want to learn about that and I want to try to benefit from that same technology too. And Red Hat and CoreOS are two such companies out there that are offering their own distributions of Kubernetes because it is open source. So the last technology we're going to talk about today, the last type of disrupting tech is serverless. And you're asking yourself, what is that? What does that even mean? Well, it doesn't mean no servers. What it means is a completely stateless compute container system, and even more stateless than what Kubernetes is doing. And the key difference between serverless and PaaS, and even Kubernetes to some extent, is scaling and the fact that it's completely automated. One quote that I thought that was important to summarize what the real definition of serverless is: if your PaaS can efficiently start instances in 20 milliseconds that run for half a second, then call it serverless. That the orchestration and the dynamic creation of instances and the tearing down of instances in an ephemeral way is truly what serverless is all about. And it's almost what Kubernetes is trying to strive towards. In some cases, what PaaS is also trying to strive for. But serverless is gaining a lot of steam too, just like Kubernetes is. There's a lot of interest in this tech, but it's fitting narrow use cases and it's still very new. There hasn't been much of a foothold in enterprises using serverless or even Kubernetes to that degree in production yet. They're new flashy technologies, but there's still a lot to figure out with them. And I bring up this example of a company like Netflix versus a company in the Global 2000 that has to deal with compliance or has regulations that amongst the industries that I talked about that are in financial services, professional services, healthcare, government, you name it. There's a difference in what Netflix does, offering a video streaming service and can play around with new types of technologies, and one in which that has to be held to standards dictated by HIPAA. And so there's a lot more to figure out when you're talking about the demands of the enterprise and what's needed for your application in order to move to a cloud platform. These technologies are great and they're very helpful, but there's more still that you have to figure out other than just deploy and scale with your cloud platform, that you have to figure out: how am I going to set up authentication for these services? How am I going to have access controls? What about configuration management, incident response, monitoring, all the key buzzwords that we're going to talk about today at the security conference, and all the domains and families you see in NIST and ISO frameworks? How do you figure that out with these cloud platforms? The other item too, and it's ironic for me to be talking up here as a vendor of a cloud platform, that there's risk associated with the products that we build, because we're adding an extra layer, an extra dependency into your data center that you didn't traditionally have. People used to deploy applications. Now it's a system in which it's automating what people used to do, and it's doing so quicker, faster, in a dynamic way based on the business needs. However, it's another attack point. So it's something to take into account, and you have the problem statement of now, how do you become a Netflix type company? How do you become a Google type company in a HIPAA compliant world, or a PCI compliant world, or maintaining NIST and ISO standards? And as we all know, and as we're all here to see Bruce Schneier will say security is more of a process than it is a product. And he's right. And Gene Kim, who is the author of the Phoenix Project, a novel about IT and DevOps. Yes, that's a novel about IT It's actually a good read. I recommend it. He would say, automate the process. And that brings us to DevOps, which is a world in which product owners, dev, QA, IT operations, and InfoSec all work together. And now you're asking yourselves, okay, that doesn't exist. But in a DevOps world, all work should be visible and transparent. DevOps borrows a lot from lean manufacturing and a lot from actually manufacturing principles that were developed at Toyota, where work needs to follow a flow. Work needs to be visible. Work needs to move from station to station in an efficient way. And ultimately, you will be able to innovate while still meeting the requirements of compliance. DevOps is a practice that's heavily automated and one that emphasizes monitoring at all stages of software development in the software development lifecycle. So all the way from a developer beginning to write code in their machine, to building that code, to deploying that code, and for IT managing the infrastructure and dependencies underneath for that code to run. And Gene Kim in the Phoenix Project and among other books such as the DevOps Handbook talks about the three ways. The three ways of work, really what it comes down to in a DevOps world. And the first way at the top is the flow, is managing the flow of eliminating bottlenecks, of work as it moves from station to station, whether it's in a manufacturing plant or whether it's in a software group, that you're constantly iterating and automating ways on how you can push code into production in a streamlined and efficient way. That bottlenecks and constraints are taken out and analyzed so that, if your bottleneck is InfoSec, you figure out ways, well, how do I incorporate InfoSec in an automated way so that it is not the bottleneck? Because sometimes the bottleneck either causes a lack of innovation or the bottleneck in turn gets skipped and you lose out on InfoSec. In either case, it's bad. So it emphasizes the continual flow of work from station to station, and I'll talk about what that means in a specific DevOps pipeline later. The second way is talking about the constant feedback and learning about your constraints, and learning about your bugs in your system, your flaws, your vulnerabilities, and iterating on them, and providing constant feedback so that you can learn and you can understand what went wrong in my stream of work. And the third way is experimental learning. How can I get feedback so constant that I can always try new things and try to improve based on what went wrong the first time around? And now you're saying to yourselves, well, that's a high level, very oversimplified way of trying to describe work. Well, in practice, it looks something like this, where you have developers building software and checking it into version control. And then it's building and compiling that software. Then you have an automated feed from that toll gate onto static code analysis, where after it's built, now let me analyze the source code. Let me see if there's any vulnerabilities. Let me see if there's any code quality issues that make, the configuration not ideal for a production environment. You move on into end-to-end and integration testing, where now you're just not testing the components of your code, but you're testing it running with other components as well. Then you can go into other types of security scanning, such as dynamic security analysis, where you're now analyzing code at runtime as opposed to code that's not compiled or code that is not in runtime. You're then able to incorporate pen testing at this point, but in the DevOps world, when you're trying to automate and continue that flow as quickly as possible, you have the ability to automate pen testing. Now, what do you ask? What would you say that is? Well, what we do at Apprenda is we deploy malicious services. We try to ensure that we have cross-site scripting protection built in on the server side, and we test for that. Make sure that with every deployment, not every release, every deployment, every day, that we're testing to make sure that we're not regressing on that functionality, that we didn't all of a sudden erase that protection. That we make sure that that's built in every time a developer checks in a new line of code. And from that standpoint, I'm not saying get rid of manual pen testing, because you need to discover new ways all the time, and sometimes only a person can do that. But if you're iterating on penetration testing every deployment, well, you're increasing your chances that you're going to find flaws that you normally wouldn't find in other mechanisms. And you don't have to wait until your 3-month, your 6-month, or your yearly pen test to discover all of your flaws and try to remedy all of them in a timely manner. This is something where you get constant feedback, constant flow back to the developer to fix something before the next deploy. And then as you deploy your services into production or even into QA or other test environments, you're constantly monitoring and you're constantly looking for what could be going wrong. What is wrong with performance? What is wrong with security? Do I have the proper controls in place? You need to automate monitoring just as much as you need to automate the transition from workstation to workstation in a DevOps world. So putting it all together, security, DevOps, and cloud platforms, the point of this talk, you can create an environment in which you can deploy software in an automated way. You can inject security into each workstation, into each area of your pipeline, so that you can test for vulnerabilities, you can test for risk, you can look for OSS dependencies. In the Equifax breach, you would know that you're running a vulnerable version of struts far before you even deploy it to production. And then you give that developer fast feedback to know that, hey, you're running with a vulnerable dependency. There's another version that has that vulnerability patched. How can you iterate on it quickly to get that next deploy in with that next dependency? Sometimes that's easier said than done because a dependency may break your application. But at least you're finding that out much sooner than when it's running in production and it's much harder to take down a production application. You also, in the DevOps model, incorporate security telemetry. And what do I mean by that? Well, in your application and in your cloud platform, you build in visible services that allow InfoSec, allow IT operations to monitor what is going on. And Google even popularized a lot of this methodology in what they call site reliability engineers. They constantly monitor for uptime, for security breaches, and they make their applications and their cloud platforms more discoverable, including notices like login attempts or log out attempts, of session locking, of remote code execution. All of these mechanisms can be incorporated alongside your application, alongside your cloud platform in an automated way, so you're discovering these earlier and quicker. And you're not relying on humans to do this manually. These are constant feeds. And it brings me to my next topic on aggregation and auditing. You're able to discover all the information, all the logging, all the auditing, if you're able to aggregate all of that into a centralized system like Splunk or Elk Stack, and you're able to discover how are users using my platform, what looks usual, what looks unusual. And building in that automation, again, allows you to discover flaws much quicker. And then a cloud platform being the last leg of your DevOps pipeline, that place where you're going to deploy your application and run it at scale, you're hooking in security as a service. You're taking advantage of crypto, of TLS that the cloud platform might be able to hook into every application. You're taking advantage of availability that the cloud platform might give you, that if all of your applications were to need high availability in another separate geographic instance, well, the cloud platform can be that replicated instance elsewhere. So then, rather than managing pets again, if you need 1,000 applications on the West Coast to also be available on the East Coast in the event of a natural disaster, you can do that utilizing your cloud platform. And the developers don't have to worry about that and manage that themselves. Another important part of DevOps is not just the actual coding and automating deployment, but it's about automating infrastructure as well and automating configuration management. There are solutions out there that help enable managing infrastructure as code. Puppet, Chef, Salt, Ansible are all products out there that enterprise uses today to build their operating system instances, to build their dependencies in. I need a Windows machine with IAS running. I need a Linux machine with Tomcat 6 running. Configuration management systems can automate those deployments, and you can add those to the grid that make up your cloud platform. And they can be a known security hardened standard that your enterprise only runs, and that any other operating system besides that is not allowed in the cloud platform environment. And you can constantly iterate and harden your infrastructure knowing that it runs in a known working state, and that it also has services that are locked down that are not needed. And then the last piece, I say here that dev should look like prod. And what I mean by that is that development should have the same hardened configuration as production. So that as a developer is creating an application, as they're building their software, or as they're iterating on an existing application, that they're building that off of the same infrastructure, using the same monitoring solutions, using the same audit log aggregators, using the same telemetry. So when they deploy to production, there aren't many changes in place. And they know that if it works in dev, it's going to work in prod. Another piece in here too that I like to talk about a lot too, that particularly this example from Netflix, but Google also does the same with SRE, or site reliability engineering, is a notion of Netflix's trademark, the chaos monkey. Well, that's a service that deploys to their cloud platforms that tries to shut systems down, tries to use up resources. You can also utilize these services for security reasons. Try to configure, a cross-site scripting attack from within inside your cloud platform. Try to do some OS command injection. These run all the time in production cloud platforms to make sure that their platforms are resilient. And just as you're watching and streaming a video on Netflix later tonight, you'll be able to know maybe in that data center that Chaos Monkey is also running, testing the resiliency of their cloud platform in an automated way so that they can iterate and discover flaws with their system. Lastly, it's just as important to secure your applications, but it's just as important to secure the pipeline too. Meaning your DevOps flow of work needs to also be secure. With new ways and new products come new risks. And I talked about that with the risks of the cloud platform. But that's not new. That technologies have come out before that have changed the way in which you do security, but also introduce a new attack footprint. Active Directory. When Active Directory came out, it's not that enterprises, decided not to store all their passwords in one central location. They just decided to do that and then protect Active Directory. The same goes for certificate authorities or CA servers. And the same goes for identity providers and security token services that enable SSO. All of these products are centralized. They provide efficiency. They make security more automated. And today they're actually considered standards. But when they came out, they were also disruptors. And it's important to recognize that cloud platforms and DevOps are a disruptor to the way in which you build software, but that doesn't mean that they're wrong. It just means that you have to take into account that you have to secure them as well. And each pipeline component, whether that was a build server, a cloud platform, has its own pipeline that it was developed someplace too. And enterprises just need to check to make sure that the development of those components also follow the principles that I talked about here today. And you should be treating the pipeline as if its own information system, meaning you should be managing access controls, configuration management, change management, authentication, availability of the pipeline itself, just as you would your applications that run and deploy within the pipeline. And that's it. Any questions? I don't know if we have much time left. Okay. Yes?
I have extended history of being deeply critical of X509 and CA infrastructure. Do you have any thoughts on securing such an infrastructure properly given the defects in the design of X509?
You know, it's actually something that's used everywhere too, so it's not going away. And if anything, what we do, we build our product to work within it because it is the standard. So the way in which you protect something like a certificate authority, you do it in many ways, but just know that crypto attacks don't come from the mathematical attack of breaking the cryptography. AES 256 takes a billion years to break. So it's protecting the centralized servers that store and generate keys. And then I would encourage, again, DevOps principles of automating the deployment of keys and automate the monitoring of CA servers and always be able to swap out keys efficiently and easily, knowing that if there's a compromise of a key, if it was stolen, because we know it's not going to be a mathematical attack that's going to break your crypto, it's going to be someone stole the key. So how can you iterate quickly and deploy new keys to your infrastructure? And something that you need to practice and always need to learn, so that when you go into production, a new key is compromised, it takes a matter of seconds to deploy a reliable secure key and to revoke the other one. So I would say some of the concepts that I talked about today are definitely at play there too. And then I would also say automate the monitoring and the analysis and the continual feedback of the CA servers as well. Treat them as your crown jewels, because technically they are. Yes.
You talked a little bit about serverless computing and how at this point in time it's a little bit of a curiosity. It's sort of a new thing, and there'll be some milestones that need to happen, I guess, before adoption is really kind of extensive. But I know one of the things that will be required in order for us to get there is to kind of build out the basic plumbing, if you will, that you use to talk to these functions, these stateless functions. What are some other things that you think will be needed in order to kind of increase the adoption of serverless?
It goes back to that slide too, if I can get to it, where you have all the demands of the enterprise. Like, serverless is helping with deploy and scale. It needs a lot more plumbing that an enterprise demands than just deploy and scale. And the same goes for Kubernetes too. And you even see this actually with the latest 2 releases of Kubernetes, where they're talking about secret and key management in 1.7 or 1.6, I believe, and then the latest release, 1.8, contained role-based access controls. That they're starting to realize the platform needs to naturally inherit and benefit from the workflows that the enterprise demands. And that's the way in which serverless is going to gain steam too, is how do I figure out ways to plug serverless architecture with my existing change management system? How do I incorporate a secured provisioning of databases and availability of those databases if my workloads are running on a serverless architecture versus an architecture that's more traditional? So figuring out those enterprise workflows is key. Otherwise, it's just going to be a playground for companies like Netflix and Google, who are going to do great things with it, but it's only because they have 1,000 people focused on that problem, and they're maybe not worried about the same problems that a bank or retail or a healthcare organization or government's worried about too.
All right, thank you everyone. Our time is up. We're a minute or two over now, but appreciate your joining us this morning.
Thanks everyone for joining.